Hey everybody, welcome to the stream. Welcome to SuperCollider week 13. Let's do a quick sound check. Make sure you can hear me, make sure you can hear my pink noise. Hey Shawadi, hey, and Parmar. Thanks guys. Okay, so on the syllabus, it says that this week we're going to talk about integrating SuperCollider with digital audio workstations via MIDI. And what I think I'm going to do is talk about that next week, and also next week touch on some live coding stuff, which I'm not an expert on, and I have a very sort of tangential knowledge and experience, but I can maybe give a reasonable introduction. But tonight, I'm going to keep talking about patterns, because we've talked about patterns before. We've done some exercises with patterns, pseek, prand, pwhite, pbind, all those things. And there's a lot more you can do with it. There's a lot more you can do with that library. And there's some clever tricks and just useful things to know that make the workflow smoother. And yeah, anyway, let's get into it. And I think what I'm going to do to give ourselves something to work with, I'm going to start by making a simple synth-def. Oh, and by the way, I'm also happy to save some time at the end if any of you out there taking 499C have paste bins for code that you're working on for your final projects. That you are welcome to send me at the end of the stream, and we can spend some time debugging and answering questions and stuff like that. All right, let's give this synth-def a frequency, an amplitude, an attack time, and a release time. And okay, let's do just a simple up-down envelope. Just go with boring old curve values, done action 2. And oh, you know, by the way, here's a fun syntax shortcut. I forget if I talked about this. I find myself typing this quite a lot, you know, typing out done action each time because it's the last argument in envgen. There's a convenience method, AR and KR, which you can apply directly to a new envelope to get the same result. So it's a little bit shorter. I don't like to talk about syntax shortcuts early in the semester because I think it might just confuse people a little bit. But you can have our same envelope here. And you got 2 brackets here. Same envelope. And then at the end of this, we do .kr. And then here, the first argument is the done action, which means we can just put 2 straight away in there. So we have an env.new. Remember, this is not a unit generator. But if we send a .kr message to env.new, then it has the effect of wrapping it in an envgen.kr. So this is yeah, sort of a syntax shortcut. Exclaim 2 times env out. I think this should do it. Here we go. Let's bring the default amplitude up just a tiny bit. So that's working. Okay, and what I was going to do to kick ourselves off here with our discussion, or continuation of discussion on patterns, is grab the Tetris example that I posted as examples of final projects. And I'm just going to totally cannibalize this here. I'm not going to copy the whole thing. I just want to grab the melody pattern, and I'm going to copy parts of this and bring it in to our pbind here. So we have a synth def, and now we can do a pbind. So a pattern that generates note events. Remember, the default event type is the note type. So this is sort of we don't have to put this line here, but we'll put it there for now. Instrument. We need the name of the synth def we're going to use. Then we need delta times between events. So I'm just going to take this here. This is bum ba ba bum ba ba bum ba ba bum ba ba bum ba bum 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 bum, and we'll start there. So these are values in beats. We might have to adjust this a little. We actually have to put this in a pseq itself. Now the first 12 notes all have the same delta times. Dun, da, da, dun, da, da, dun, da, da, dun, da, da. It's all the same. So we just do a pseq and do that 4 times. Then we have the rest of the phrase. And we'll do that whole thing forever. And then, now we do have a freak argument here, but it would be kind of silly to do freak, because then we'd have to put the actual frequency values in hertz, and it's a diatonic melody. So fortunately, we don't have to do MIDI notes. We could, put MIDI notes and then do .MIDI CPS at the end of them. Or simpler is we can just put MIDI note here, and the default event takes care of that for us. At the bottom here, we have this hierarchy of frequency information. So instead of freak, we can specify MIDI note. The one rule here is that we have to have freak defined in our synth def. Otherwise, we have MIDI note and it just doesn't work. So we'll just grab those. I think, yeah, there's the A's at the end of the first phrase. We need to put those in a pseq. Just stay on one line, please, please. There we go. All right, now I think this is going to be, it's going to, well, there's lots of problems here. Well, let's, just very, very slow. Let's put amp in here as well. So you can hear it's working. It's just that these happen to correspond to values in seconds. Technically, they're values in beats, but this brings up the idea of a tempo clock. Now, okay, we can be really sloppy and just, maybe it's not that sloppy, but we'll just multiply all these values by 0.2. And right, so that works. So we can just sort of arbitrarily scale these integers, which are seconds, however we want. We can make it really fast. Okay, but that's I mean, what if we want to specify a tempo like normal musicians? Like, I want this to be at 140 beats per minute. It's like, how do we make this a quarter note at 140 beats per minute? It's annoying. We have to do a lot of like math, and it's not actually necessary to do all that. You can do it that way. You have, this is seconds per beat, or it's a value in beats, and you can say, okay, this is a duration, so it's seconds per beat, and say beats per second, and then beats per minute. It's very confusing. So the first thing I want to point out is that if we open up parentheses at the end of the play message, play is defined for a lot of classes, one of which is pattern. And patterns, when you play a pattern, it is scheduled on a clock. And by default, it is the default instance of a class called TempoClock. let's take a look at TempoClock. So this is a class, we've probably seen this once or twice before. It's an accurate clock, but it's based on a tempo rather than a value in seconds. So we can create a new tempo clock and give it a tempo. This is a value in seconds. Nope, it's a value in beats per second. The default value is 1, so 1 beat per 1 second. This is why you can easily make the misconception when you play your first Pbind. You're like, oh, okay, these are values in seconds. Well, yes and no. Yes, they are, because the default tempo of the default tempo clock. And so there is a tempo clock running as long as the language is running. And we can access it with TempoClock.default. And if we say TempoClock.default.tempo, we get a value of 1. So it's running at 1 beat per second. So beats equals seconds. So when we say play and just semicolon right after that, Pbind says, okay, I'm playing. I guess I wasn't told otherwise, so I'll just play on the default tempo clock. And that's why these values correspond to seconds. Now, if we want these values to correspond to beats at some other tempo, well, we can make our own tempo clock. T equals TempoClock.new. And then we provide a tempo, an initial time in, the time in beats, and then the reference time in seconds. I really don't mess with these. Whenever I make a tempo clock, I just give it a tempo. So if we want 140 beats per minute, we can't say 140 because it's going to interpret this as a value in beats per second. That's really fast, 140 beats per second. So we divide that by 60, and we get 140 a tempo clock running at 140 beats per minute. So now, if we play this, instead of just relying on the default tempo clock, we just say play this on tempo clock T. And just to confirm the difference here, I'm going to command period on that. If we just say play it on TempoClock.default. Right? Very, very, quite a bit slower. So depend on TempoClock T. But it's not quite what we want. I guess it's not the classic Tetris tempo. That's because this is 2 beats. Right? We've got 140 beats, or 140, I guess, quarter notes per minute, and we really it's quarter, eighth, eighth quarter, eighth, eighth quarter, eighth, eighth. So we have a couple of options. We can make the tempo clock twice as fast, or we can just divide. Well, if you want to think in terms of I guess you could do something like you get the idea. I think the simplest thing to do is just cut this in half. Right. And we could even change the tempo. So the tempo is currently, 140 over 60, which is 2 1/3. We can even just change the tempo. Let's slowly bring it up. And speeding up. Bring it back down to 70 beats per minute. Yeah, so that's a little taste of tempo clock. Let's stop the pattern. Okay, and before we get back into Pbind land, it's something that might initially be kind of frustrating about tempo clocks is that if you make a tempo clock, it's there and it's running and it's keeping track of beats and stuff for you. So we can say stuff like t.beats. How many beats have elapsed? And we can just keep evaluating this. And we can see this number is going up. These are how many. This is a floating point accuracy beat. It's the current beat when we say, it's running. It's running in the background at its tempo. We can also do stuff like t.next bar. And that gives us the number of the next, the beat corresponding to the beginning of the next bar. And you can see that, it's somewhere between 96 and 100. Now it's between 100 and 104. And if we were to post ln t.beats.postln, we can see, so here the next bar is 124, and we were at beat 122 point whatever, and so it keeps track of all this stuff and we can access it. The disappointing thing is that when we make, it would be great. It's probably possible with some sort of Quark or something. It would be great if we make this tempo clock and then a little metronome GUI pops up or something and we can see stuff like that. But it's not too hard to get a tempo clock to post information about where it is in the post window. And you can do that by scheduling stuff. Like we can say t.sched abs. There's two options here. Sched, which is a relative time. You give it some number of beats from now. Or there's sched abs, which is you give it an absolute time in beats. So we could do something like, and here we provide a value in beats that it's assumed it's going to be in the future. We can say t.next bar. So this is like on the next bar, evaluate the function. So here I'll run this, and it was pretty quick here. Let's try it again. Yeah, a little bit longer. So we could also do something like t.beats.postln and hello.postln. Yeah. So it was right it's the next, the beat corresponding to the downbeat of the next bar is 156. So a Quark is like an extension or a plugin. If you type quarks.gui, you get this window. And you have all these things that other people have made. It's like classes and collections of classes, which are used for all sorts of different things. I am not a big Quark kind of guy. I tend to go with the vanilla language, even though I'm sure some of these are crazy useful. You can see I do have a couple of them installed, which I've just sort of messed around with. But you can just click on one of these. It'll download it from GitHub, I guess. And then you just recompile the class library. And then you can start playing around with it. Yeah, Quarks are just like third-party extensions that people make, because SuperCollider's open source and you can mess around with it and add stuff to it. So that's a Quark. Let's see. So anyway, that's so. What? And if you let's see, if the function that we schedule with a scheduling command ends with a number, it is scheduled again that many beats later. So now we basically have a little metronome, right? Maybe we don't need this hello. So I think, yeah, how do we unschedule this? I think, well, I probably should have named this function something. So I think just for now we can do t.clear. And I think that clears everything out of the scheduling queue. But if I can say, post beat equals the function t.beats.postln semicolon 1, and then what we can do here is post beat.value in another set of curly braces. So I think this should work, right? We've got our little metronome counter once again. So we have a function which posts the current number of beats of TempoClock t, and then returns a 1, which causes this function to be rescheduled that many beats later. And then we actually schedule it. Now, what's nice about this is that we can say, okay, post beat is now the function that returns nothing. And this way we can free individual things from TempoClock. Okay, that might be enough about TempoClock. Primarily, I want to introduce it just because it's a nice way to be able to specify a tempo in beats per minute. And then for your duration pattern, you could just specify beat values. You don't have to do weird divisions and stuff like that to get weird tempos. Of course, you can. You can just ignore the tempo clock and use the default tempo clock and scale your duration pattern however you want. But I think this is a little bit of a cleaner way to do it. All right. So, I mean, if you have more questions about TempoClock, feel free to ask. It's a useful thing. Whenever I'm writing live interactive stuff that's got synchronized elements to it, I will very frequently use a TempoClock. Other things you can do with it, you can change the number of beats per bar. You probably notice that these are all multiples of 4, so the default number of beats in one bar is 4, but you can change that, and you can also schedule changes. You can say, you know, at the next bar plus 16, so the next bar plus another 4 measures, change your beats per bar. Let's say t, if we say t dot beats per bar is 4. So what we could do is copy this, and then this is, I promise, this is the last thing I'll talk about TempoClock, because these patterns are more fun. Let's get into that. So we'll say t dot beats per bar underscore is now 3. So t dot beats, yeah, this is 4. It's not changing, and we'll say change dot post ln, and then do that. So we're still at 4, and yeah, it changed it. So now there's 3 beats per bar. So if we say something like t dot next bar, now it's some multiple of 3. So it's a very flexible object. And if you look at the help file, it's really clearly laid out all the different messages that TempoClock understands. Okay. Now the next thing I want to talk about is the fact that it's not particularly intuitive to specify a complex melodic, the rhythm of a complex melodic, semi-complex melodic pattern like this. Because if you'll notice, these are not metric, it's not the duration of the note, right? It's not the sustained time of each note. It's the amount of time to wait before scheduling the next event. It really doesn't say anything about how long a note, like if it's sustained or if it has a long release or a short release. And, you know, I guess if we can just simplify this a little bit, so maybe it'll be a little easier to see what I'm talking about here. We'll just say, so now it's just laid out plain as day. And just looking at this, it's not really clear to me. You know, my brain doesn't translate this into a like, oh, I get the rhythm. I can. It's not like reading music for me. You know, I can see things, quarter notes, eighth notes. It's just a bunch of numbers, and you know that can be kind of hard to read. It still works, obviously. And this gets especially problematic if you start to have weird syncopations or things that don't come in on the downbeat, and you'll start to get just, you know, it just gets hard to read. That's all I'm trying to say. So I would like, this is how I did it in this. I mean, this is basically how I did it. I have these duration patterns, which are just these more or less unreadable sequences of numbers. Like there's a 68 over here. I have to wait 68 beats for some reason. And, you know, it's just a lot of numbers. It's not that easy to read. There's a better way to do it, which I sort of, oh, Alan, that's a good question. Good way to change TempoClock linearly. What I would do is make a routine, which is basically has like, I don't know, let's say you're at a tempo of 100 and you want to go to 200. You can make 100 dot 200 dot do t dot tempo n over 60, and then, you know, something like this, and then play the routine. So we can do n.postln, or actually let's do t.tempo.postln. So if we make a tempo clock at, yeah, just to finish up here, at 100 beats per minute, and then we play this routine, yeah, there it goes. And once we get to the end of that, we should be getting there soon. Yeah, the routine is done, and now t.tempo is 200 over 60, or the 200 beats per minute. That's what I would do. I don't know if that's the best solution, but that's a quick and easy way to do it. No problem. Happy to help. Okay. So right. As I was saying, this is kind of like sloppy and unreadable and not something that can easily be modified. So there's a different type of event called the rest event. And if you look, there's actually an object called rest, which represents a rest. So if we play this now, yeah, it's not even making any synths. It's just it's just sitting there. Let's stop it though. And if we change this back to note, right. So the rest event is actually really handy. It seems kind of silly in like it maybe at first glance, like the silent unit generator. It's like, what do we need that for? Who knows? But the rest event is actually pretty handy because of how it's implemented. So just first of all, we can subject our event types to patterns. So for now basically we're just going to sequence. We're going to note rest. So every other note is going to be a rest. And I guess it's got an odd number of notes in it, right? It's, yeah, 19. So you get the idea. A rest event is, there's only two components. There's only two ingredients in a rest event. It is the type of event, which is specified with the symbol rest. That's how we know it's a rest event. And the only other ingredient is the delta time, the amount of time to wait before scheduling the next event, whatever kind of event it happens to be. So all this stuff, when we get a rest event, all these other keys, the synth def we're using, the MIDI note, the amplitude, it's all just, the rest event just says, I don't care. I'm a rest. I don't need that. You know, I'm just going to ignore that. And it does. So now we could, okay, so the reason rest is really handy is because, and this is really cool, expressing rests in event patterns. In addition to the rest class, rests can be specified in two other ways. A symbol may be specified in any frequency stream under the keys degree, note, MIDI note, or frequency. Don't worry about this exception. So basically, a symbol is just, you know, anything with a backslash before it. And this means we don't actually have to worry about these wacky long lists of delta times anymore. We can just think about our melody, whatever, and think what's the shortest delta time in there, and it's the eighth note. Like there's no there's no 16th notes. It's just eighth notes, 1 and 2 and 3 and 4. So we can just say eighth notes, right? So we'll say P, seek. Actually, yeah, we can do it. So if yeah, so just 1/2, right? Because it's half of a beat, and a beat is a quarter note. And so a 1 here is a quarter note, and so half of that is an eighth note. And so we just do that. Every event, the space between the onset of each successive event is always half of a beat, or we're thinking of it as an eighth note. If you want to do something like this and say, I want an eighth note, that is 1/8 note, that's fine. Just make sure that you do this and just multiply by 4, because the difference here is that 1 beat is a quarter note, but if you want to think of that as 1/4 of a bar, you have to multiply by the number of beats per bar. So I guess you could also do this. T beats per bar. Yeah, 4. So now we're not quite done yet. If we play this now, we're gonna have the same. And let's just do note events. Just note events for now. Yeah. Okay, that's what I'd expect. Because but now what we can do, and is we can say, all right, let's now. Let's write this pattern out. So we have, they're all eighth notes, right? But this one's not. It's a quarter note, or it's, maybe you could think of it as an eighth note followed by an eighth rest, right? And we're thinking, okay, hold on, we're specifying a value of the symbol rest for MIDI note. That's surely going to give us an error message, but no, it's not, because in all of these frequency patterns, degree, note, MIDI note, frequency, if it encounters a symbol, then it becomes a rest event instead of a note event. That's basically what happens. It's just it turns into a rest. So if we play it now, you'll hear an eighth note on the what is that? An E, MIDI note 76, a rest, and then 71, 72. Yeah. So then we put a rest here. So you see where I'm going with this, but it's you don't actually have to type. I mean, you can type whatever you want here, because a symbol is a symbol. It doesn't actually read the symbol or care what's in the symbol. All it needs to do is identify that it's a symbol. And there is, in fact, the shortest symbol possible, which is just a single backslash. So here, I think, is where it really makes a lot of sense to use a monospaced font, because then you can line things up, right? Here's the next. So here's the first bar. You have, eighth note or quarter, eighth, quarter, eighth, or however you want to think about it. So then we have, got one here, then we have two, So I find this to be more intuitive. It starts to look a little bit like music, a little, maybe not a lot, but I just find it's more readable, and we can do even better than this. MIDI note, I think, is not the best choice here. Well, freak is terrible. We don't want to specify frequencies. MIDI note is okay, but I don't know. MIDI note's not the greatest thing to, like, I'm not fluent in MIDI note. I can't look at like a 74 and be like, oh yeah, I know what pitch that is. I have to like count from, I know 72 is a C, so that's a D, but it's not, So anyway, this now should sound like our Tetris theme. Yeah. So that is the primary consequence of the rest type of event. Is it means you can just think of your pattern as an evenly spaced grid of your smallest durational value, and then just do that value forever, right? And if you want to think in terms of like classical music theory and stuff and think eighth note, 1/8, that makes sense to me. You just want to multiply by the number of beats in your bar. And then you can use a monospaced font and then tidy everything up like this, and it reads better. At least I think so. I don't know. Hopefully you think so too. But let's actually go into the bottom of the event and look at this event hierarchy again. We have frequency. We have MIDI note. Then we have something called note. And then we have degree, scale, and M transpose. This is sort of the lowest level. So MIDI note, those are MIDI notes, right? 60 is middle C with a frequency of 261.6. 69 is the A, tuning A with a 440 hertz frequency. For note, I think the way it works is if you don't mess with any of these others, note 0 corresponds to middle C, and then it's chromatic. So 1 is C sharp, 2 is D. I think that's how it works. We can test it real quick. Let's copy this just so we don't destroy it in case we want to come back to it. So let's just give ourselves a little bit of space, and we'll say note seek, and we'll go 0, 1, 2, 3, 4, 5, 6. Let's just try that. Yeah. Right. So it's you could do a C major scale like this. Which I don't think this is that much of an improvement over MIDI note. In fact, I think it's maybe even a little bit more confusing, just because I don't know. It's still just. Oftentimes we want to think diatonically, not chromatically. So like we want to think like do, re, mi, fa, sol, la, ti, do instead of like a chromatic scale. But anyway, just to keep with note for just a little bit, we can say, I mean, probably octave is going to be the octave transposed. Let's just try this. Oh, that's not right. What is octave normally? Oh. Oh, I see. So this is giving us, right, that's not going to help us. So octave shifts, I guess, this way. G transpose. I'm sure this is going to give us like half a step up. Yeah. Okay. So it's in, I think note and MIDI note are kind of similar. It's just sort of a different configuration. You can mess around with that, and you can change the number of steps per octave, and the ratio of the octave does not have to be 2:1. So you can do some weird microtonal stuff. So I feel like Dongrel would probably be excited about that. If he's watching, I don't know. All right, but then degree, I think you will find is really good if you are composing a melody which is like in a key, you know, it's like in C major or in A minor or whatever. So let's get rid of these because they don't belong there anymore. And the way this works now is to 0, 1, 2, 3, 4, 5, 6, 7. So now the tables have turned a little bit. We're doing these, you know, integers, but they don't correspond to a chromatic scale, half steps anymore. Now they correspond to degrees in a scale. And we can specify a scale with the scale key. And we can say scale, there's a scale object, scale, which represents a music scale. If we say scale.directory, we get a string, a long string in the post window, giving us all of the different built-in scales, which is cool. We can do scale.choose. That's defined for scale. It just spits out a random scale. You know, harmonic major, Ionian, Locrian. And it tells you some information about the degrees, the tuning system, equal temperament, 12-tone equal temperament here, and the name. But let's just do, major I think is the default. Scale.major. If we do minor. Let's do triangle waves. I feel like the sine wave is, I don't know, it'll be a little bit richer with a triangle wave, maybe. And we can do, what, is there some sort of minor, there's melodic minor, just what I thought, yeah. So, yeah. I bet it does not, I bet it does not correct it going down. No, not a true melodic minor, but actually, I'm not sure how you. I think if you want to do chromatic stuff, degree might not work. You have to define your own scale or something. I don't know. I just don't use degree that often, but it's good for Tetris, and I'll show you. And I guess we're ready to do that now. So now humans mostly start thinking at the number 1. So you think of scale like in a C major scale. All right, okay, Tetris is in A minor, so we'll do A minor. A is scale degree 1, right? And if you're ever taking a music theory class, the tonic, the root is scale degree 1. It's not scale degree 0 because we're not computers. So anyway, I when I'm thinking of, you know, the Tetris melody, I'll start on 5, you know. So it's and this should be just regular minor, I think. Yeah, so we have dun 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 do. So it's so easy to just type it out. You know, you can do it in real time basically. You don't have to think about MIDI notes and accidentals and half steps and and certainly don't think about frequencies at all. You just specify these. And then because SuperCollider thinks of 0 as the first scale degree, you can just do this. And then if you don't like that -1 there, you could even just evaluate it and then paste it back in. But this is fine. I find this is very readable. 5, 2, 3, 4, 3, 2, 1, 1, 3, 5, whatever. So we'll just do that forever. We're not quite done, but let's play it anyway. Right. So now we just need our rests. And what's nice about degree is that these are all single-digit numbers. Oops, what'd I do? Let's get that. Let's do that. And so now we can just stick in our single character rest here. Oh, yeah. The scale directory has a melodic minor descending, so I suppose you could sequence that. Yeah, probably the right way to do it is to subject your scale key to a pattern. And basically, do a p-seq maybe. Maybe there's an even slicker way to do it. But thank you for pointing that out. I missed that. Yeah, melodic minor descending. Interesting. Okay, so let's put in our rest now. Oops. Yeah, when I figured out this symbols as rest things, it just sort of changed everything for me. So now you can even just like use white space and just make your 4-bar phrases like this. So we can do the next part of the phrase. Let's start with just the notes. And so there's a and of 1 here. You get the idea. So I just love this. I think it just looks really clean. And yeah, so scale, degree, and then there's also what is it? M transpose. So that'll bring it up a half step. No. It doesn't bring it up a half step. What it does is it preserves the key, preserves the diatonicism, and it just shifts all the notes up 1 in the scale. Right, so A's become B's, B's become C's, C's become D's. Right, so it's a, what does the M stand for? Probably modal transposition. Yeah, so if we were to go like down 2, this would up to be in the relative major. Major Tetris. Yeah. So that's degree. That's fundamentally different. If you're thinking in terms of scale degrees, like something you'd play in a key, degree is the one to use. Yeah. So you pick a scale and you just write your do re mi's basically. Okay. The next thing I want to do is cook up another synth def. We'll just add it in with this one. And this one is going to play a sound file. So I guess we'll just initialize that at 0. Amplitude. We'll just have a release time. And a playback rate. We'll just copy this and maybe change it a little bit. I just want single release. So it just starts on. There's no attack whatsoever. Just instantaneous attack, and then we go play buff. Oh, we should load a buffer, shouldn't we? What I was gonna do is make a little drum beat or something with like, I'm just gonna use a single kick drum, but change the rate to make it into like sort of a hi-hat and snare drum as well. All right, let's go find a sample. And let's see, kick drums. So you can click and drag a sample like that, and that works just fine. But did you also know you can do copy and paste? That also works. So in hotkeys, of course, you do Command C, Command V. So this is the little kick drum sample, and it has 2 channels, I think. Yeah, 2 buff rate times env times amp. And now let's see if that works. Yeah, and then if we change the rate to like 4, yeah, tiny little clicks. So this is going to be a pretty cheesy, kind of weird beat here. But let's cook up a quick pattern here. Something different. We'll just call it, we've got the first one called P. Guess we might as well go with the flow and call this one Q. And so let's see. So if now you might be thinking, well, okay, let's just start here. Let's keep our tempo clock here. Let's just want to be able to evaluate that without having to scroll up. Put this here. Let's do our 8th notes again and rate. Something like this. Oh, we need to know what buffer we're playing, right? And I guess we'll set the amp to be, let's bring this one down a little bit too, so we're not having any clipping or anything. And then the release, well, it's fine at 0.1. Play this on TempoClock T. All right, so what if I wanted to do something a little more interesting, rhythmically complex, so like or something. So if we want to do a couple 16th notes in there, we're gonna have to take this down a bit. And rate is not a frequency pattern. So first of all, let's just see what happens if we do this. Yeah, doesn't work. It yeah, rate this symbol trick only works if you're sticking a symbol into a frequency, MIDI note, or degree pattern. So we can't use this trick here, but we can just specify any old frequency pattern, or we could do MIDI note or degree or note, and like there's no frequency in this synth-def. So they're harmless values, but they're still actively being added to the event, and if any of these is a symbol, it becomes a rest. So let's go back and change this to 16th notes, and our PC, we're gonna have 16 rates, right? It's gonna be a like half a bar loop. So we'll start at 1, and we'll go two of them way up here, and then like a 25, and then 5. But I want it to be something like 1. So this is going to be, but we can't put these symbols here. But we might as well keep them there, and then we'll just copy this here. And these frequency values don't matter, I think. Yeah, so now if we didn't have this, we'd get this, where all these rests get translated into the default rate. So we get 1, 1, 100, 100, 25, 1, 5, 1. So this doesn't work. But then as soon as we add a frequency pattern with those same rests in the same spots, they become rest events. So this is silent, silent, silent. We get this. Right? And I think maybe we can even get fancier with this. There's a pattern called P-key, which simply gets the values from a previous key. Oh, it works. That's awesome. So you can treat your rate pattern in the same way. Just we have a note on every 16th note, on every quarter of a beat. And if the ones we want rests, just make them rests, like with symbols. And then just set any old, we can also do note. I think that'll work just the same. And P-key just copies the values from the rate key. And if it encounters a symbol, it puts a symbol here, and then the note type event becomes a rest type event. So yeah, that's pretty fancy. So let's get rid of this for a second, this TempoClock, and we'll start this pattern. Oh, I don't want this. I want I want regular Tetris. So we'll just get rid of this M transpose. And maybe I want to start our drum beat. Oh, I did way better than I thought I was going to. It's not perfectly synchronized. Maybe I can do a worse job to get my point across. That's not as good. You can hear that they're not perfectly lining up. They're running on the same tempo clock, and they have these nice even durational values. So they'll stay in sync, but they're not, their phase is misaligned. And I can just start this whenever. So a really sensible thing to want to do is to be able to synchronize two patterns so that they start at the same time. So, okay, obviously we could do this and just put them all in the same clump. And that's fine, I guess. But, it's sometimes when we're composing a piece or working on some project, it's like we want to have some element playing that's maybe rhythmic, and we want to be able to add something to it later and have it lock in step and just be right there on the beat. So the way we do that is using an object called Quant. So this is a class which provides functionality for quantization. Encapsulate quantization issues associated with event stream player and TempoClock. That's exactly what we want. So we don't actually do anything with like quant.new. I guess we could, but that's not how I do it. If we open up these parentheses again and go down to pattern, we see that the first argument is clock. The second is something called proto event. I'm not going to mess with that. And then quant. So I think there we provide an instance of quant, but I think we can also provide a single value, which is interpreted as the first argument for a new instance of quant. And I think we can also provide an array of 3 values corresponding to the quantization value, the phase of the quantization, you can get it to start 1 beat earlier or 1 beat later, and then a timing offset. It's been a while since I've messed with these, but let's give it a try. And let's also do t.scedabs. Do I still have that code, or did I delete it? Yes, that's what I want. I want that. Oh, by the way, by default, a new TempoClock will be destroyed by command period. So it's gone, right? And if we say like play this pattern on T, nope, T doesn't exist. What's the message here? Clock is not running. Command period destroys a TempoClock, but we can do dot permanent underscore true. And then if we do command period, I think it's still there. It should still be there. So if we do, yeah, it was still running in the background. I think command period also has the effect of clearing the scheduler queue. But if this was false, oh, how do we destroy a TempoClock? T dot. Oh God, I don't know how to do this. Place clear. Is it clear? I don't think it's clear. Yes, stop. It's just t dot stop. And so now I think that's the same as if, yeah. So if this is false and we hit command period, I don't think we're allowed to do this anymore. Right. So anyway, if you find yourself, if you're debugging and testing stuff and you're constantly having to scroll back up and make a new TempoClock, just make it permanent, and then you don't have to worry about it so much anymore. So I kind of like mine not being permanent. Just I don't know. It doesn't really matter. So I just want to see the beats, and we'll put this in its own clump and separate the cue pattern a little bit. And we're going to skip over the proto-event argument and just say quant : 4. And this will quantize the pattern so that it starts on the next beat that is a multiple of 4. I think that's how it works. And you know, we could even, let's just make our TempoClock first and make this later. So here we go. So if I hit this, it should start on the next available multiple of 4. So I'm going to try to hit it just after 40, and it should start on 44. Yes. And so now, whenever I feel like it, I can just, you know, say quantize this one to 4 as well. I'll have it come in on the second 4-bar phrase right here. Yeah. So that's quantization. It's really, really quite handy. Let's see what else. Any questions so far? Let me see if I can mess around with this phase thing. So in Quant, is there a section on using it with patterns? So Quant 1, schedule for the next whole beat. Quant 4, phase -1, a 1-beat pickup. So basically this will start on the next beat, which is immediately before a downbeat. Yeah, Quant 3 schedules with a phase of 1 would schedule on the next multiple of 3 plus 1, so 1, 4, 7. And yeah, let's try that. Our clock is still running, so we'll just starts on the next multiple of 4. And let's do, gosh, I think we can do, I don't know if this is going to work. I think if you provide an array for Quant, it's going to make Quant 4 phase 1. So it should start 1 beat late. And I'll try to have it start on the downbeat, and we'll see if it's 1 beat late. Yeah, that makes sense. And just to make sure you're not overlooking this or anything, it's totally legal to use floating point values here. Like I can start it, you know, a third of a beat after the downbeat. And now it sounds like I'm just sloppily starting them by hand. Anyway, that's quantization. It's really handy. It's not too hard to figure out when you want to lock things together. It really makes for a very elegant system, especially as we get into sort of live coding with patterns, which I think is the last thing I really want to talk about today. This has come up in the semester a couple times already. The question has been, you know, I've got this pattern playing, and I want to change it, but I don't want to stop it. And if I want to make the amplitude quieter, I can't just, I mean, I can, oh, you know, I'm live coding, so it's playing and I'm going to reevaluate. It makes a new Pbind, right? It plays, and it overwrites the old P. So if I do P.stop, it stops the quiet one, which was like out of phase. But now I can't stop this one anymore. So I have to do like command period, I guess, which also destroys my TempoClock and stuff. So if you want to change a value pattern within a Pbind, one option you have is to enclose it in a Pdefn, and then you want to give it a symbol name. We'll call it sine amp. My system for this is I'll just take the name of the instrument, or maybe the name of the pattern is better, you know. So the name of the pattern is P, the name of the event stream player is P, and then the symbol is amp. So I'll just do P_amp or something. And now let's start our TempoClock again, starting back at beat 0. Hey Beetle, how's it going? And then we will quantize this. And now that amp is in a Pdefn, Pdefn is a little pattern which basically keeps a reference to this value and allows us to update it on the fly. So that's a handy tool. And, you know, I have this very simple thing going on here, but I can do like, let's leave that alone. And let's add a release pattern. I think I have a release in this synth def, don't I? Yeah. It's been at a static 0.8. Yeah, you totally could. That's what I'm going to do. It's just not going to be very interesting with amp, I think, or I'm just going to try to do something with release instead. So, you know, let's say we have let's make it a little bit longer. So 0.2. Whoops, our TempoClock is dead. So we'll make that again. So now we'll do prel. And it doesn't have to be a fixed value, right? We can put patterns inside of patterns. So we'll do pexprand between 0.01 and 0.5 forever. Or maybe we want pseek, or no, we'll do, yeah, pseek array.geom size 8, 0.5, 0.8. So this is going to give us, this is going to sort of fly by in the post window, but it's just getting shorter every note, I think. Nope, what did I do wrong? I need another parenthesis. So it's working, but some of these values are essentially being wasted on REST events. You know, so if let's stop the pattern for a second, and let's just put this here. We'll initialize the pattern that way. Oh, what? That's not what I copied. I want this. Yeah, if computer scare, if that's what you're suggesting, I hope this answers your question. So TempoClock. Maybe I should make my TempoClocks permanent. I don't know why I want them impermanent, but. So you can hear the beginning of each measure has this 0.5 release, and it's sequencing through this array of 8 values that get increasingly smaller. So I don't know if that's, maybe that's what you want. It is possible to basically only use these values if we get a note event. I know how I'd do it. And maybe it's not the best way. I think this is like my refrain here. I'm just like, I know this is how I would do it. It's probably not the best way, but whatever. That's how I do it. So let's see if we can do that real quick, and then we'll move away from Pdef and talk about some other interesting patterns here. So I'm gonna take this here, and we're going to say relpat equals this.asStream. Right? So now we have it as a simple routine. So we can just say next, next, give me the next, give me the next, give me the next. Right? And for the release, we're going to do pfuncn. This is a pattern which takes a function and returns a value based on the evaluation of that function. And we're going to have this go forever. What's nice about the pfunc, this one here, and also pfuncn, is that inside the function, you are allowed to declare a single argument which represents the current event being generated by the played pbind. So we can just say arg ev, and then once we have the event, we can treat it sort of like an array or a dictionary, because that's kind of what it is. Event is a subclass of dictionary, which is a type of collection. So we can say if this is some advanced stuff right here. If event at degree dot, I think there's a method is symbol. Yeah, that is a symbol. 2 is not a symbol. So we can basically check the degree value and say if it is a symbol, then just it doesn't matter because it's a REST event. So this value doesn't matter. It's the release time for a REST event, and that's just an ignored value because REST is a REST. So that doesn't really matter. We can even put like nil there or some garbage there. It just doesn't matter. But if it's not a symbol, it's a note, and then we want to say relpat.next. Call the next value from this stream, and that's it. So this is a function within a pattern. We have this lovely pattern here, which every time an event is generated, it's going to evaluate this function. It checks the degree and says, are you a symbol? If so, it's just some junk value. Oh, if not, you're a number. So let's get the next value from the stream. And so now what's going to happen is this is going to have the longest duration, and then 8, 7, 6, 5, 4, 3, 2, 1. This is the 8th non-symbol degree. And so that's going to be the end of this array. And then on the scale degree 3, it's going to go back to the beginning and start at this 0.5 duration. At least I think that's how it's going to work. So let's try it. Yeah. Yeah. So I mean, this is kind of a stupid example. It's not very musically interesting or compelling. We're just kind of making a random sequence of release times which are applied to the notes. But I'm coming to find that pfunc and pfuncn are just so incredibly useful because they're patterns, but you just provide a function where you can specify whatever sort of logic you want, and you could even access previous keys using so you just have a lot of control over pfunc, pfuncn, over what you want to do. So I've gotten a little bit away from Pdefn, but basically, Pdefn is a way you can just wrap that around one of your value patterns, and then it becomes available to you outside of the pattern. As the pattern is playing, you go onto a new line, and you just reevaluate the Pdefn, provide the symbol corresponding to the one that you want to. So I guess maybe we'd go back to our amp example here. Yeah, for example here. Let's this pfunc is interesting, but I think you can even just overwrite it in the next statement. Like, what? Oh yeah, I pushed command period. So there. That's an interesting consequence, is that I have this rel pattern, and then I just redefine it right after. So all of this work is completely overwritten. Now we just have 0.08 again, and then we can use Pdefn to change the amplitude. We can do and now it's instead of a constant value, it's a pattern, a px brand, choosing random values between 0.05 and 0.8. So that is Pdefn. How's everybody doing? Chat's been awfully quiet tonight. Always just worried that the stream is dead, but actually people have been talking. Just want to make sure everyone's following along, and all that jazz. So there is a class called Pdef. Wonderful, Shwadi. Thank you. Alive and well. Pdef is very much like Pdefn. The difference is that Pdefn is meant to be wrapped around an entire pbind. So I think is symbol isn't working for me. Are you getting an error? It should work for everything. Message is symbol not understood. Whoa, it's defined for object. So oh, it's an extension. Oh, well, that would explain it. Casually using extensions. All right, well, maybe we could think of some other way. Like, we got to think of some message that, what about is integer? How about that? Yeah. Just reverse your logic. There might also be an is number. Yeah, is number. That is what I would suggest. Is number, unless that's also an extension. No, is number is that's vanilla class library stuff. So that's what I would do instead of is symbol. Just use is number, and then just swap your, don't save that, please. Swap your true and false statements. Oh, that's good too. Yeah, that's another good one. Spacetime is dot class equals. I think it's you want to do this instead of a. I don't think this is gonna work because that's always gonna be false. But just capital S. Yeah, that's a better idea rather than hunting down some. Cool. Is integer works for me. Yeah, but spacetime definitely has another good idea. Just check the class of the object and compare it to the actual class. So, yeah, good stuff. Okay. So Pdef is, let's see if I remember how to use this. It's like Pdefn, but instead of putting it around a value pattern, you put it around an event pattern. And the benefit here is that we no longer have this need for a global variable q. Instead, it's like MIDI def, synth def. It's all the def classes where the first thing we give it is a symbol. I guess we can keep q. And then a pbind. And then we play the Pdef. Yeah, we want to put the Pbind in here, but then play the Pdef. And this might have to change. This I'm not sure about, but let's put it back on the downbeat. And let's just see if this works. Seems like it does. So now, let me just load another buffer. Let's see if we can get a buffer without losing our minds. Let's do a low bongo. Okay, fine, whatever. Maybe not the greatest sample in the world. But now what we can do is just switch any one of these. And then maybe also change some other stuff. You know, and then I think if we just reevaluate this. Oh, it's got the wrong number of channels. Boo. Why do some of my samples have 2 channels and some have 1? I'm so irresponsible. I thought they all had 2. But I think it's working, right? Let's change it back. It's not quantizing quite exactly as I expected it to. Yeah. Okay, so I have this tutorial 10. At the end of it, I briefly talk about Pdef, and my vague memory is that the syntax for quantizing a Pdef is a little bit different from quantizing a Pbind. I think it's like we do play .quant _4. Let's see if this works. I got to start my TempoClock again. Don't know if I can remember this exactly, but we'll start with B. What? Didn't like that. Maybe it's .quant .play. Oh, now it's not doing anything. I still have these, don't I? Well, it's not playing on. It's okay. So I think it's like a proxy event or something. A proxy space proxy player. All right. Well, I don't know this much about Pdef because there's an even better object, and It's an object called Pbindef, which is like a marriage between Pdef and Pbind. So it's got a lot of the same syntax as .play quant. For Pdef, let's see, does that work? Let me try this. I'm just hearing nothing though. Is this still working? Ugh. Let's go back to this for a second. All right, TempoClock. All right, I'm sick of this. Permanent. So we play this on T. Yeah, and then if we say Pdef Q, dot play. Look at the example here. Let me do a find for quant. Any examples? Oh, okay. It looks like they set the quant first and then play it. So if we do something like this, Pdef Q, let's clear it first. Q dot quant underscore, good lord, quant, and then an array. We'll just say 4. Let's say 4. I think it'll probably fill in the default values that we need. And then if we play it on T, let's see if this works. Okay. This is a common thing I've seen in a lot of the live coding classes like Pdef and Ndef and stuff, is you sort of make the item first and you set attributes for it. And then after it's like playing, then you give it something to do. So if we clear this again, set the quant Pdef Q dot play on TempoClock T, it's playing, you know, it just doesn't have any data. And then we can just give it some value, this pbind. Yeah, I think that seems to work. Oh, look at that. Help file was helpful. That's nice. All right, so now I think we can. Let's see if it still quantizes. Yeah, I think it does. So then let's get this out of here. It seems like it's now always quantized. This is the syntax. This you take the Pdef object dot quant underscore parentheses array of a quant time or something. All right, and now we can just say Pdef Q dot stop. And if we play it again, is it still quantized? It is not. Oh, I just played it on the default tempo clock. So that screwed everything up. So stop, play. Okay, fun stuff. So Pdef is pretty useful, I think, if once you remember the syntax. Do we need the quant in the play as well? No, you don't. You quantize the Pdef object. Basically, Pdef is this sort of higher level class that sort of understands all the same messages. I think it's actually a subclass. It's a subclass of pattern. Yeah, it's but so no, you mean in the play message, you know, when we play it here, the quantization configuration has already been set. So here we're just resetting it, we're making it completely empty, it's a blank slate, Then we say Pdef at the symbol Q has a quant value of 4. Now we're going to play, even though it's empty, we're going to play this sort of empty pattern on TempoClock T, and then we can just freely provide the Pdef with a Pbind. We don't have to play the Pbind because the Pdef enclosing it is already playing and quantized and ready to go. So we can just reevaluate this. We can change stuff in our Pbind and then reevaluate. And this is one very tangible approach to live coding, is you just initially set up 10 or 12 Pdefs. They're all running, and then you can just fill them with stuff in real time, and they'll just do their thing. All right, the last thing I want to do is Pbindef. Pbindef is, the syntax is a little bit similar to Pbind, but it has all the functionality of Pdef. It's actually a subclass of Pdef. So everything Pdef does, this also does. So the way I use Pbindef is let's do this. Let's just it means we have less of a need for all these parentheses, and I might get the syntax wrong again here, but we just need a symbol first, and then we do our symbol value pairs. So it looks something like this. We have a Pbindef, and then we play it on TempoClock T. Let me double check here how we quantize this. Is there a quant somewhere? Okay, so it looks like the syntax is similar to yeah, so if we do clear it first, quant 4, and I mean, right now it looks like it's exactly the same, more or less, but it is a little bit fancy in what it can do. So I think if we do this, this will start again. And what's nice here is that we don't have to reevaluate the whole thing. We can just specify the Pbindef we want, and then one of the patterns, and it'll only change that pattern, like this. Right? Or we can maybe specify the release isn't going to do too much because it's a sample and it's a percussive sample anyway. But we can do, let's bring the amplitude back up. And then we'll just say rate is now pxbrand 1 to 100 inf. Yeah. And notice that we've also gotten rid of our rests, right? So we could do like a prand and choose either a rest or a pxbrand that just chooses one value. And so now it's a 50% chance we'll get a rest, and that rest will get copied into the note key and it'll become a rest event, or we'll just choose some random value once, but this outer prand is being evaluated forever. So you can make this just low values. But the changes only take effect on the next beat corresponding to the quant position, the quant configuration of the Pbindef. Ham boning. Yeah, and I think Pdef and Pbindef actually share a library. So even though this is technically Pbindef Q, so we can stop it, like we can clear it, I guess, or stop it. Right? Let's randomize it again. I can also do pdef.q.clear. Yeah. So what Pbindef Q and Pdef Q refer to is actually the exact same thing. So they share a library. It's not like I can't think of a good example, but Pbindef and Pdef are really very, very similar. The difference is mainly in syntax and the fact that Pbindef lets you just run a single line and update a single pattern, a single value pattern within a larger event pattern, so you don't have to be evaluating the entire thing. They're both pretty handy. I think I tend to favor Pbindef over Pdef for no particular reason. I think I just learned about Pbindef later, and so I'm more excited about it because it's like, oh, Pbindef, I know about that now, so I'm going to use that instead. That's all I've got. This is sort of a first take at like more advanced techniques with patterns. I think some of the material here might become another tutorial in my series on like patterns part 2 after I clean up my act a little bit, because I'm like constantly, you know, live streams are live streams. They are what they are. So I'm going to open it up to anyone out there who's been working on their final project and is stuck somewhere. You can paste bin your code to me, or even if you're not taking the class and you've got a question about stuff, if you want to send me your code, I can spend some time looking at it. Happy to do so. Yeah, go for it, in Parmar. For a second, I thought that said meme, like someone was memeing in my chat. There's only going to be one last homework assignment. It's going to be just some granular synthesis stuff with patterns, and that's the last thing I'm going to ask you to do. I bet you'll be able to complete all or most of it in class. It's just, I just want to do one more thing with patterns, because the first pattern assignment was just kind of really, I don't feel like it got the point across. It'll be fun. It'll be relatively easy, and then no more homework. So yes, I am already planning to reduce the amount of homework so you can do your final projects. All right, let's take a look at this. Okay, this is the synth that's controlled by the GUI. The problem is I can't pass an end as an argument. Right. So yeah, you always want to avoid putting global variables here. So I think what you want to do, I mean, what if you, oh yeah, passing an end, I mean, okay, my initial thought, which may not be sufficient for your purposes, is to do, you know, something like this, and declare all these arguments. Up here. So we have like level 0, level 1, level 2, and you're welcome, do rules. Oh, wow, I can't count. Okay. So, you know, this would be like 1 second, time 1 would be 1 second. Curve 0, I guess you can just make these linear if you're not doing any curves. and then whenever you move the envelope GUI, you take its value, which is that array of stuff, and you calculate from the values in the array the appropriate values to dump into the synth as these individual arguments here. I think that should do it. I'm going to think about this a little bit more, because my brain is telling me that there is some normal, sensible way to do exactly what you want to do. It's just not hitting me at the moment. An alternative approach, I'm not recommending this, but it is possible, is you can take an envelope right, here's that envelope, and you can discretize it. Let's give it 8,192 points, and it becomes an array, I think. No, a signal. And basically you can load this signal into a buffer and use playbuff or buff read instead of envgen, and just store. Whenever you move the envelope, you take the envelope, you discretize it, you load it into a buffer or overwrite a buffer, and then playbuff, you can re-trigger the playbuff and it'll read through that buffer which contains that envelope shape. Right. Yeah. My approach is limiting in that way, in that here you're stuck with 3 points. Yeah, I guess I'm starting, the more I think about it, the more I think the playbuff approach might be sensible, because you can set playbuff to loop. It has a loop argument, and you can also manually re-trigger it. Yeah, the way we do that, let me look that up real quick, and I'll get to the other good questions I see. I'll get to Alan's question in just a second. I think maybe it's the buffer help file. I don't have this syntax memorized, but I think it's load collection. So let's see if I can do this. E equals, so now E is this signal, and let's see if I say B equals buffer, good lord, buffer dot load collection SE, and now if we B dot plot, yeah. So now this is actually, we're plotting a buffer which contains 8,192 discrete points, which correspond to that envelope. And then if we make a sound function like this, and I'll make the stereo, and then env is a playbuff, one channel, buffnum, b.buffnum. I'm being really sloppy here, but just to give you the idea. Oh no, it's a little more complicated than that, because we have to do some math to get the time information correct. Because right now it's maybe buff read would be better. One. Oh, I'm not going to be able to. I think I just need to think about this a little bit more. But whichever one you end up using, maybe playbuff would be easier. And then the rate, if we do a rate of 1, it's going to read through 44,100 samples per second. And so it's going to get through that buffer, which has 8,192 points in, whatever that amount of time is. So it's going to be like 0.1857, etc. seconds. But let's just confirm, and we'll loop 1. We're going to loop that. Sig equals sig times n. Yeah. Uh-huh. So that's working, but then we can say 0.5, 0.25. So you'll have to do a little bit of math here. Something, probably some sort of division operation, which involves the number of samples in the buffer/signal and the sampling rate, and also involving your time scaling stuff here. You have your period argument. But with those values, I mean, I know you're a CS engineer type, so I feel like that's the kind of problem you'd be able to sort of figure out. But that way, all you have to do is when the user clicks on and drags the envelope, what you do is you take that envelope, you create an envelope based on the current shape, you discretize it, and you load a collection with a buffer. You could free the previous buffer and load the collection. Maybe this does introduce some like latency or whatever, so it's actually going to take a second to update. And I'm not claiming this is the best way to do it, but it does avoid the problem of having to pass in an envelope as an argument, which I think is not possible. Yeah, because the server only knows about floats, and ugens are just calculations with floats. But env.new, yeah, it's a little bit different. Anyway, I hope that gives you something to chew on. It's a good question, and if I come up with an obvious solution, I'll let you know. So Alan was asking, is there a way to call another function when one pbind is finished? Yes. My gut reaction is to go with putting a send reply in a synth-def. And then, its trigger, you just make your pbind the last event that your pbind generates, trigger that send reply, and that'll send an OSC message from the server back to the language, and then you have an OSC def listening for that send reply message, and you can use the OSC def's function to start another pattern. Is there an easier way? Probably. I mean, okay, I don't know if this will quite work for you, but there is well, okay, you can just put a bunch of pbinds in a pseq. Right? Like this. And then play the pseq. And it'll just start with this pbind and just keep generating events. If this pbind is infinite, it'll go on forever. But if it's finite, as soon as it's done, this one just starts immediately. And then when that one's done, this one goes. And you can probably put pdefs in here, so that the pseq starts on this pdef, and it can be infinite initially, but then you can just reevaluate the pdef to be finite, and then as soon as it's done, the pseq will move on to the next one. Untested, but that's my hunch is that would also work and would allow you to have one pbind start as soon as the next one ends. I guess that's not the same as your question, which is how to call a function when one pbind is finished. I feel like you want to sort of think bigger picture and like what's the actual structure of your larger code, and maybe there's some more sensible way to structure the logic and not have to rely on the action of a pbind ending to trigger some function. Yeah. Can you pass arrays as arguments to synth-defs? Yes. Very common question. Not one that I have dealt with many times. The simplest answer is that they have to be literal arrays. And a literal array is specified with a # before it. And you can declare arguments as literal arrays. Right. So if we now say like x equals x dot add the number 4, we get an error because a literal array is immutable. It can't be changed. So it's like it has the same staticness as an integer or a float or something. It's just a static value, right? This array is what it is. It's always going to be size 3. It's always going to contain 1, 2, 3. But when you declare an argument as, let's see if we can do this real quick. Arg freak equals 440, 770. Let's do like 280. The array, this, that, and we'll just use splay to spread these out over the stereo field. And we'll set this equal to like x, I guess. So that error is from a previous thing, right? That's working just fine. We've got 280 in the left, 440 in the middle, 770 on the right. And now we can say x dot set freak so now this is going to be a different collection of frequencies. So I think that's the way we do arrays as arguments. If we get rid of this, what happens? That seems to, oh, it doesn't even play, right? Or, yeah, it doesn't even play. Why doesn't it play? So that works. That does not. I think it's because this is not a literal array, it's a regular array, and it's one thing, and the resulting unit generator called control that gets created in the background, I guess, has a value of nil. I don't know for sure. We're getting a little bit into the deep synth-def building stuff here, but you make it a literal array, and then if we do this, oh, that works. That's cool. I guess it automatically becomes a literal array. Okay, so as long as you declare it as a literal array, that's totally allowed. If that answers your question, Beetle. Dakuch, yes. I guess if you want. I don't know how helpful I'm going to be because I don't really know C#. And computer scared. You know of a way to play something into a buffer but not in real time. For example, write 10 bars of a pattern to a buffer without actually waiting the 10 bars in real time. Yeah, but I don't think, I mean, okay, what you want to look into is NRT. I think this is what you want. I've done this once, and it was a long time ago. Basically, what happens is you just get to write a score of some kind. It looks something like this. You know, so we have this array, which consists of these sub-arrays, which are times, you know, server commands, the name of a synth-def, the node ID, the add action, the arguments, and yeah, so there's an NRT synthesis, and there's a score object, and then we can say score.write, and then it will just execute these OSC commands and render out an audio file. You know, here's an AIF 44100 sampling rate, AIF format, 16-bit, and it's gonna be called score-test.aiff. And so I think you make, you know, like the example here, we do, instead of .add, we do write def file. And then here's this here. We create a score with X's, it's with this format here. And then we do score.write. I'm getting some error here. I'd have to mess around with this a little bit. Could not open. Oh, maybe I didn't create the file first. Yeah, I think you actually, if you start here at the top and follow it step by step, like first you create a file and make it writable, then you do a bunch of other stuff, and it's fairly well commented. I've done this once. It's pretty cool. And you can also, of course, use the SuperCollider language to algorithmically generate scores. You don't have to type it all out. You can, you know, and so, right, then you just write a score and render a file by calling a Unix command. That's how you should do it. And it shouldn't be too hard. Yeah, you're welcome. You can have arrays as arguments through the #. Yeah, the # makes an array into a literal array. I mean, this is so common of a question. It's, you know, a lot of new users end up wanting to declare arguments that are arrays. And I think if you go to the wiki, which is like really old, see if I can find it real quick. SuperCollider. Let's see if I can find it. Okay, yeah, it is here. So I'm on the, I think if you go to supercollider.sourceforge.net, you can go to the wiki, and it's not the wiki. Is it? Yeah, this is really old, but I don't know when this was last updated, but in user FAQ, there's array arguments. Sometimes you may need to send an array to a series of control inputs, right? Two primaries to do this: supply a literal array as the default for the argument name in the function, or use a class called named control. Yeah, so this way you can, you know, forget about making an argument, just make a variable and do the class named control. Treat it, it's like a, I think it is a UGen. Let's look at this real quick. Named control. No, it's not actually a UGen. It inherits directly from object, but it's a class that's involved in, yeah, it directly combines a control name and a control UGen conveniently. So you just say .kr, you give it the name. This is then when you actually specify it. This is as if you declared an argument called freaks, and you provide a literal array. So the key is a literal array. The wiki also tries to explain why it has to be a literal array. And long story short, it's a consequence of design. So that's that basically. What am I making? Well, nothing right now. I was just talking about SuperCollider patterns and sort of a more advanced, you know, some more advanced techniques using SuperCollider patterns and quantizing and stuff like that. Yeah, one of your tutorials, live streams. Something to be careful about when using out.ar and providing an array of signals. Yes, I do remember what that is. First of all, let me make 4 output bus channels and reboot the server. And now we have 4 output channels. Okay, so now let's say, okay, so let me just double check what you wrote here. Using out.ar and providing an array of signals as the second parameter. Yeah. So let's say we have stereo pink noise. And we're going to say, you're going to go out to, let's start with just mono pink noise, right? Something really simple. So we just have a mono signal and we're going to play it. And it comes out on the left. If we send it to bus 1, it comes out on the right. If we send it to bus 2, it comes on bus 2, but we don't hear it because I'm going out of my laptop's headphones jack, and it's just got a stereo sound card. So it's there, we just don't hear it. Now, let's say we have stereo pink noise. Now, this is the correct thing to do. This is correct. You just say, go to bus 0, and SIG is a stereo signal. It's been multi-channel expanded. And so, the server's like, okay, I'll write this to bus 0. Oh, and it's got another channel, so I'll just put that on bus 1. If we made this into a quadraphonic signal and played it on bus 0, you'd see the first channel on bus 0, and all 4 of these would be filled out, like that. So that's fine, but it's sort of like, I've seen some people do this. I've done it myself earlier on, where you say, okay, I've got a stereo signal. I want to write this to bus 0 and 1. And this seems like an innocent enough thing to do, but it's wrong because this is what happens. We have sort of like a little pyramid thing going on here, where what happens is out.ar is writing a stereo signal to 2 buses. So, oh, hey, Scott. So what happens is the server says, okay, so on bus 0, I'm going to write this stereo signal. And also on bus 1, I'm going to write this stereo signal. So what happens is it goes to bus 0 and says, I'm going to write the stereo signal here. So it shows up on 0 and 1, left and right. And then because we provided an array here for the bus, it also goes to bus 1 and says, okay, left on bus 1, right on bus 2. And so we get the left and right signal both on output 0. So in this particular case, this has the effect of making the right channel, the right ear, slightly louder. So it's just not what we want. This is okay, a mono signal and writing it to 2 buses like this. This will put the same signal on both buses. You can see they're moving exactly the same. It's exactly the same signal. It's basically, it's the same signal in both speakers. And if you make it stereo, you should just write it to the lowest numbered bus. And then it just goes in numerical order, 0, 1, 2, whatever, however many channels you have. But if you have a stereo signal, don't also do this. That's a mistake, because then you get some weird behavior. Does that make sense, Computer Scare? Yeah. Yeah, no problem. Okay, I think that's a good place to stop. So keep working on your final projects and be in touch with me if you get all sorts of questions and you get stumped on stuff, and send me your paste bins, send me your SCD files, send me all sorts of stuff. I'm going to cook up a not a very challenging assignment, but I do want to talk about patterns and granular synthesis, because patterns, Pbind is just a great platform for doing granular synthesis. And granular synthesis, for anyone who doesn't know, is taking some recorded sound and breaking it up into very small time segments, which are called grains, and then basically creating a new sound from recombining and restructuring those individual grains. And so you can do pitch shifting, you can do time stretching, you can garble sounds completely, and you can like sort of freeze a pointer so you get the same sound over and over again. It's really cool. So I'll just have like 4 or 5 examples. I'll give you a sound file. You make a synth def that plays a short segment of that sound file, and then use a pattern to create certain effects. It'll be fun, and I hope it'll be useful down the road. And that'll be it for in-class and take-home assignments, because I know everyone's working hard on their final projects, and I do not want to overburden you. So yeah, I think that's it, and I'll see everybody in class tomorrow, and next week will be the last stream of the semester. Even though we do technically have class the Wednesday after that, I think what I'll do is I'll just meet with anyone who wants to meet individually. But yeah, next week we'll talk about some DAW integration using Pbind to generate MIDI events. I also have a tutorial on that, tutorial 18. And briefly, I guess, get into live coding with NDef, which is like Pdef. Pdef is for patterns, what NDef is for synths and groups. Cool. So Schweity's got a whole bounty of icons there. Love it. Okay, so yeah, thanks everybody for watching. I'm gonna head out, and I'll see y'all next week. See you in class tomorrow, and all that good stuff. So yeah, thanks. Have a good night.